Hi, good day to you all. Welcome to another physics class. So we are still going to continue the topic specific heat capacity. But this time around, we're talking about mixtures. Mixtures of different temperature, whereby there is going to be heat transfer. Now, if you're wondering which one is heat transfer, which one is mixtures, a simple illustration is this. You wake up in the morning feeling cold. You open the valve of your tap to get water inside the bucket. Now the water has its own temperature. You felt, oh no, this temperature is too low. You can't take your bath with this kind of temperature. So now you decided to boil some liters of water. Now that water you boiled will also have its own temperature after boiling. Now, note the temperature of the water you boiled. Note the temperature of the water in the bucket. That is temperature 1, temperature 2. After boiling, you decided to add the water into your bucket to mix the water, isn't it? Now the temperature would also be different. Now the initial temperature of that water you got from the tap will be lower. Now the resulting mixture is that hot water you poured inside the water. There is heat transfer. One is going to gain, the other is going to lose. Now how do we know the one gaining? How do we know the one losing? The water in the bucket, in which you have already released from the tap, has a temperature, let's assume because it's cold, let's assume 15 degrees Celsius. After adding your water from the boiled water, after adding your boiled water, mixing it, now the water will become warm for you to be able to use it to take your bath in the bathroom. That water would have a rise in temperature. Yes, the resulting mixture will have a rise in temperature, let's say 40 degrees Celsius. So the water in the bucket is the one gaining heat because it was initially 15. Now it is 40. Which one is losing? The water you boiled have already reached its boiling point of 100 degrees Celsius, isn't it? After boiling, you added it to the water in the bucket. Definitely the temperature would have come down from 100 to that 40. So it is that hot water that is losing heat. The cold water in the bucket is the one gaining heat. So when it involves mixture, there is usually heat transfer, heat gain, heat loss. So these two must be balanced for you to get your calculation right. And that is what we are talking about today. The heat losses and the heat gain. Now let's look at this first question. A piece of iron of specific heat capacity 0.04. Now let us write out all the parameters. Remember, in physics or chemistry, if you have any question, the first thing you do is to write out your parameters. It will enable you to know what you're actually calculating and how you go about your calculations. Now let's write out the parameters. The piece of iron of specific heat capacity this. So let's say the specific heat capacity of the iron is 0.04. And mass of the iron is 400. Now, it's quickly dropped. That means it was the one eaten and was quickly dropped into 30 kilograms of water. What is the mass of the water? 30 kilograms. This is the temperature of the water before that iron was dropped. Temperature of the water, 10 degrees Celsius. Now this water was told, okay, we were told here that the water is contained in a calorimeter. Now what is the mass of that calorimeter? 120 kilograms. And what is the specific heat capacity of the calorimeter? 0.1 joules per kilogram per Kelvin. Now after this mixture has been carried out, that is the hot iron, drop inside the calorimeter containing water. This is the resulting mixture. The resulting mixture is 30 degrees Celsius. Now here we are told to calculate the initial temperature of that hot iron. The hot iron that was heated, we don't know its initial temperature, but we're told that the resulting mixture is 30. So the temperature of the iron is what we are looking for. Specific heat capacity of water is 4,000 200. So let me adjust my lens for proper viewing. So now let's go. Let me demarcate it. Now, we already know that its loss equals to its gain. It must be balanced. Let's start with the its loss. Must be equals to what? Its gain. So let's start with the its loss. Which one is losing its? Because we already know that the iron will have its initial temperature, but the resulting temperature is 30. Now, the copper calorimeter and water has initial temperature of 10, but the resulting is 30. Definitely, the water and the calorimeter are the one gaining it. So, the iron is the one losing it. So, mass of the iron times specific heat capacity of the iron times change in temperature. So, what is the mass of the iron given to us? 400. What is the specific heat capacity? 0.04. Now, the difference in this temperature is going to be, we don't know the initial, because definitely the initial will be bigger than the resulting, the final, because it is losing. So here we'll say just theta minus, what is the final? 30. So now let's use the calculator. 400 times 0.04, that should give us 16 or thereabouts. Let me confirm. 400 times 0.04. Good, that's 16. So we have 16 theta minus 16 times 30 will give us 480. So this is the its loss. Let's go to the its gain. The its gain, let's start with that of the water first. Mass of water times specific heat capacity of water times the change in temperature, plus mass of the copper calorimeter, specific heat capacity of the calorimeter, times change in temperature, because the two are together. The water is contained in the calorimeter. The calorimeter and the water are the one gaining the heat. So now let's start. What is the mass of the water given to us? 30. 30 times specific heat capacity of water, 4,200. What is the change in temperature? That will be 30 minus 10. Plus, okay, let me just find those ones and for all. The mass of water is what? 30 times 4,200 times 20. So this one will give us a total of 30 times 42 times 20. And that will give us 2,520,000 joules. Now the calorimeter is the next one. What is the mass of the calorimeter? 120. What is the specific heat capacity of the calorimeter? 0.1. Temperature change 20. So we have 240 joules. So add these two together, we have 240 joules. Is that taken? Okay, to complete it, let me just rub off this other side, since we don't need a question again. Now, let's equate the two together. Its loss equals to its gain. Its loss equals to its gain. What is our its loss? 16 theta minus 480 equals 2 million. So making this one the subject of the formula, to add this one to this, and we have a total of 252. 480 plus this will give us 720. We divide both sides by 16. So your temperature will be equals to 2,520, 720 divided by 16. And that will give us 157,545 Kelvin or degrees Celsius. That's our temperature. Oops, very, very high. Very, very high. Is that taken? I'm just in the process. First of all, highlight your parameters. Highlight everything given to you. Then you should be able to dictate from here the heat loss, the one losing heat and the one gaining heat. Okay, can we proceed to the second question? So that means I will have to rub this off. Let me rub this off too. Okay, now let us write out the parameters as usual for the second question. Copper of mass 50 kilogram. So we have mass of copper 50 kg at a temperature of 10. The temperature of the copper is 10 degrees Celsius. And we have a copper calorimeter having a mass of 15 kg. It has water inside it. Please note this question. The copper calorimeter weighs 15 kg. Now inside the copper calorimeter we have water. So the total mass of the copper calorimeter and water is 40. So how do we know the actual weight of the water? So for us to get the mass of the water, you just say 40 minus 15. And that's 25 kg. Is that okay? Let's go. Now, when heat energy is involved or supplied to the calorimeter, the temperature reaches 50. That is the temperature of the mixture. The temperature of the mixture. Now we are told to find the specific heat capacity of copper. Given that specific heat capacity of water is 4,200, the specific heat capacity of the calorimeter is 400, and the initial temperature of the calorimeter. The temperature of the calorimeter is 54 degrees Celsius. Can you see my analysis? So here, the first thing we have to do is to dictate which one is gaining heat, which one is losing heat. Looking at the parameters, the copper started with 10, and the resulting mixture is 50. Definitely this copper is the one gaining heat because it started with 10 and ended up having 50 degrees Celsius. Meanwhile, the copper calorimeter containing water, we are looking for the temperature of the copper here. Or what's this? We are looking for the temperature of the copper, while the temperature this is the initial temperature of the calorimeter. This is the initial temperature of the calorimeter, 54. And the resulting temperature is 50. So definitely it is losing heat. For the temperature to have come down, it is losing heat. So we already know which one is our heat loss and which one is our heat gain. So for proper understanding, let me just rub the whole of this place off and solve it here. Sorry about our board. No worry, I'll get a bigger board soon. Okay, so now let's go. Let's start with the heat gain. Which one is gaining heat? Copper. So mass of copper times specific heat capacity of copper times the change in temperature. What is the mass of the copper? 50. What is the specific heat capacity of copper? That is what we are looking for. So just write C. Now what is the change in temperature? Copper started with 10 and ended up having, where is the mixture? 50. So that will be 50 minus 10. So now here we have 50 times C times 40. So we have 2000 C here. Is that okay? Now let's go to our heat loss. Remember, under this heat loss, we have two things involved, the copper calorimeter and the water. So let's start with the copper calorimeter. What is the mass of the copper calorimeter? Mass of the copper calorimeter is 15 kg. What is the specific heat capacity of the copper calorimeter? That is 400. And what is the change in temperature? That will be 54 here minus 50. 54 minus 50. So what is the mass of the calorimeter? Here, 15 times specific heat capacity 400 times 4. So what do we have total here? So we have a total of 15 times 400 times 4. That's 24,000. 24,000 joules. That is for the what? Copper calorimeter. Now, for the water, mass of the water times copper calorimeter of the water times the change in temperature. So what is the mass of our water? 25. 25 times, what is our specific heat capacity? 4,200 times 4. So we have 25 times 42 times 4. We have 42,000. So here we have 42,000 joules. Remember, heat loss equals heat gain. So which one is losing here? So we have 24,000 plus 420,000 will give us a total of 2,000 C. Yes, they will be equal. So now here we have 24 plus this, that will give us 4 equals 2,000 C. Divide both sides by 2,000. Bam, 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 bam. So our C here is what? 2, because it is specific its capacity. That will be joules per kilogram per Kelvin. Is that taken? Yeah. Look at our parameters and look at the way I slotted it in to get our answer. Is that taken? Okay, we'll continue next class. Bye.